Hi everyone. Hi everyone. Welcome back to the channel called Engineering Beyond Blueprint. Still so far we have been as we segmentize two things in electromechanical components. So one we talk about brief about each of the electromechanical components and types of electromechanical component and their applications, and we understand bit of brief on high level parameters when we compare a different set of electromechanical components. So today what we do, we'll little bit get deeper into understand what are those critical parameters when we combine together as a switching components called relays, contactors and switches. Likewise, I do had segmentize three different categories so that we can get deeper into each of the technical parameters and understand when we are recommending a alternative solution, how we have to accounted all this critical component and how do we can find a recommended solution. Let's get started with some of the key parameters of switching components called relays, contactors and switches. So key parameters, if you ask me, all these three major components falls into like majorly on the coil voltage. So when we say coil voltage, like relays and contactors and switches depends on the coil functionality, right? It should be match. So the coil voltage should be matched. We should not be, you know, should not be minus or positive side. It should be matched basically, right? So next comes for contact rating. So when we say contact rating, when we are toggle switch or any other switches if you taken, so it has on and off functionality. So when it contact in either side of it, the contact rating we defined into voltage and current load capacity, right? So it should be match again. So contact material. So again, this is very important. It defines the reliability and how durability of the component, right? So general contact materials are Ag, NSO and Ag, Ni, and I mean nickel for inductive load. So electrical and mechanical life, number of cycles defines the reliability of the any electromechanical component, specifically in switching components, right? So then next comes for operate and release time. So it's basically define the switching response. So when we operate at a certain speed and all, how quickly it's responding, and is equally important when it operates and when it release time. So utilization category AC1 to AC3 categories define the contactor load capabilities. So that comes to the reasoning for why we have to choose exactly the same value, why we should go for higher value, and reasoning for understand when we are recommending the alternative solution. So always use the 12 volts coil instead of 5 volts. If there is a existing components operate at coil rating at 5 volt, then use the 12 volt because it's consume low current and better noise immunity and simpler for drivers. So derate contacts by 1.5x ratio, right? When I say handle in rush and prolong for lifespan, so always better to choose 1.5x ratio. So selected contact material would be superior for inductive loads and reduce the contact welding. Add flyback protection. So extend the relay contactor like their life by suppressing the coil spring. So as I said, right, the relay or switches, anything, if say there is an contact between the spring and spring operate at a certain speed at given human interface on the spring. So use manual switches with greater than or equal to 2x load rating. So prevent the premature wear, right? So ideally for automation and motor controls, protection circuit and power panels, these are the switching components called relay, contactors and switches will be used. So next comes as a second part of components categorized as a motion components. So when I say motion components, it's inclusive of motor, stepper, servo, and linear actuators. The electromechanical motion components are their critical parameters and parametric recommendations. So what are those critical parameters, right? So voltage and current, definitely that is needed. Driver compatibility and thermal load, right? Key parameters, these are all like voltage and current always, driver compatible and thermal load. Torque rated stall, it determines the real usable force of the any of these motion components. Next comes for speed. See, any of the motors like operates at certain speed. We define into RPM and the torque curve, the performance under load. So that defines the speed and the torque curve. Next comes for duty cycle and thermal class. Continuous versus intermittent motion, right? So duty cycle and the thermal class defined based on the motion of device. Next come for gear ratio and screw leads. So speed torque trade-off is basically when there is a torque trade-off defined based on the gear ratio and screw leads. So feedback type, so open loop and closed loop. So that is the feedback type, and rotor inertia is acceleration capability. So basically define the acceleration capacity when it comes for rotor inertia. So when we are recommending alternative solution, right, there should be some reasoning for all these critical parameters. When I say torque margin, right, the torque margin would be greater than or equal to 1.5x of time. So prevents stall under real world and load spikes. So that is the reason we are choosing the torque margin greater than or equal to 1.5 percent. So choose BLDC overload over brush DCs, right? So why we are using BLDC? Reason is it has its high efficiency, longer lifespan, and better to control. So it's more precise than compared to other motors and motion component. So use the closed loop stepper instead of open loop. So why we use the closed loop stepper instead of open loop? Because it eliminates the missed steps and smoother rotation. So closed loop always is a better. So pick the gyrometers instead of oversized motors. So why gear motors? Because more efficient torque multiplications and optimized speed. At a step-by-step level, the motor can be operated at a certain speed. So next comes select ball screw actuators for precision. So why we are selecting the ball screw actuators? Because it's it's a low backflash and higher mechanical efficiency. So higher voltage motor, example 24 volt instead of 12 volts. Why we are using 24 volts? Because consume low current and reduce the heating and better dynamic response. So ideally, these motion components are used in robotics, CNC, and EV system automation equipment and industrial machinery. The third segment is I categorize as a sensing and automation components. So when I say sensing and automation components, are components called solenoids and encoders and HMIs basically. So the key parameters are stroke length and force solenoids defines the real actuation capabilities. Next comes for duty cycle. As you know, many solenoids are intermittent duty only, right? Response time is also equally important because it's required to be locking and injecting and valve usage, and encoder resolution is PPR or CPR. So parts per rotation and is continuous part rotation. I guess I need to kind of share more insight of it, but it determine the position accuracy. Next come for interface type. So we do have different interface, as you know, TTL, RS232, and SPI, right, and even SSI. So noise immunity and cable length. So that defines the interface type of all these sensing and action components. So next comes for environmental protection. So IP rating, dust water resistance, so that we need to see, right? So mechanical life and bonus switches, it tells about like how reliable the component is. So when it can come for alternative recommendation with some reasons, right? The force of the sensing and actual component, sorry, actuation components, it defines the force greater than or equal to 1.5x required because solenoid force drops with strokes. Use the continuous duty solenoids or switch to motorized actuators. If long hold time are required, then we have to use the continuous duty solenoids. So choose RS232 or RS422 encoders because it differential for noise and long cable runs. It is a differential signal resistance at electromagnetic interference. Select absolute encoders because it retains the position of after power loss and essential in robotics and safety system. So even the power is gone off, this obsolete encoders will help a lot. So pick IP65. As you know, this is used for water resistance, even for outdoor and industrial usage. Prevent the dust and moisture induced time, right? Induced failures, so that cause for failure sometimes. So use low bonus and optical switches. Reduce the fast triggers in digital system. So ideal for robotic feedback, mechatronics, industrial sensor, and lock walls and consumer devices. So I hope this could help a lot for you to understand what is mean by electromechanical component and how this is critical when it comes for converting from electrical to mechanical or mechanical to electrical signal, and where and all these electromechanical devices are used across. And nevertheless we understood different type of electromechanical devices and their critical parameters, and we understood when we are recommending a solution why the reasoning we are choosing high voltage or whatever the reason, right? So that defines overall as an electromechanical device how critical for any given application or usage. So with that said, I guess this tutorial or the exploration of electromechanical devices components help a lot for you all. So with that said, thank you for watching, and please do like, share it with your friends and families who willing to be grow in the industry to understand all these basic um, passive or active components or understanding of electromechanical devices, how play a critical role especially in the real world. So with that said, thank you for watching. Please do keep support and have a great day.